Hello, analysis. Sorry about the delay on getting this video out. But hopefully we can get back on track. And we'll be talking about some of the stuff we've recently accomplished and some things to look forward to in the coming weeks. So on the agenda, I just wanted to give a welcome to our two new members, then talk about the actually final fin shape, uh, then the software trade study, which was completed, and then the four kind of major upcoming tasks I see us completing in the next coming weeks. And then if you have any questions, I guess just shoot me a message on Discord. So welcome to Charlie and Preeth. Huge shout out to both of them. They've both been added to analysis and just wanted to give them some guidance on where to start because I know it can be a little intimidating at the beginning. But first thing I think you guys should both do is visit the Spaceport America Cup website and read up on the competition. We're competing in the COTS 30K category. So that means most of our materials for our rocket are going to be bought from commercial vendors, and we'll be trying to reach 30,000 feet. The link to the Google Drive is here on the presentation. It's the source for all of our material, the work, and everything that we do. And then also the onboarding presentation, which I gave last semester, kind of goes more into depth about the structure of the sub team and how we operate. It is a little long and some of the information isn't accurate just because it was so long ago. But I guess if you're wondering about how we work and how we get stuff done, then that's a good resource. And then obviously the Discord, please don't be afraid to ask questions. I know when I started, when Urban started, when all of us started, it's good to just ask questions, even if you think they're stupid. Just, yeah, don't be afraid, and we'll answer them as fast as possible. And then some more resources. I found a website, thanks to Gustavo, just about rocketry in general, and it has as basic or as complex explanations of things as you'd want. So it's linked on the slide there. And then the most recent February progress report, just so you can see kind of the recent tasks that we've been working on and read about what we've completed from our PDR up until now. Also wanted to quickly talk about our split up of analysis. We're currently split into two, I guess, sub teams. The first being the design team, whose main responsibilities include CAD, FEA, or finite element analysis, and CFD, or computational fluid dynamics. They will be focused not on learning NX and PMAP anymore, but kind of learning theory behind FEA and taking care of all of those related tasks that come their way. And then validation team is kind of just a catch-all for everything else. So they're working on apogee simulations, system validation, and then occasionally mathematical models. So mainly in charge of OpenRocket, and as I'll talk about later today, RockSim. And then I guess just, yeah, anything else that comes to mind for the team falls into validation. So jumping right in, our final fin shape, our work with fin design is actually finished after literal months of working on this. So huge shout out and thank you to everyone who contributed. I really appreciate it. And I know it was really tiring and annoying to be working on fins for such a long time and, looking at comparisons on OpenRocket and then switching to FinSim. But with that being said, our final fin shape has a root chord of 13 inches, a tip chord of 1.5 inches, a semi-span of 7 inches with a sweep length of 15 inches, and then carbon fiber for the material. It has a 1.23 factor of safety for divergence velocity, and the industry standard that we've researched was found to be 1.15. So we are over that. And then for fin flutter, obviously we're not too worried about it. We'll be clear for both of those. The carbon fiber sheet was actually just purchased. And then Dom's dad's water jet cutter is how we'll be cutting them out, because we'll be purchasing that carbon fiber pretty much square. And then trying to cut those out using a water jet. And then I'm talking to Irvin, and hopefully we can try and be there when it's cut, because I know we haven't done literally anything hands-on. So being there, maybe learn more about water jet cutters, and then I guess just seeing how the fins will be cut, I think would be pretty cool. So I'll see if we can get out there soon. Then the FEA software trade study is also complete. So huge shout out and thank you to Omar, Arturo, and Nico. They concluded that we should primarily work with SolidWorks and then also be open to using ANSYS for FEA in the future. I think it was necessary to have this trade study just because of our issues with FEMAP in the past and all of the, I guess, learning curves and time that it takes to become comfortable with the software. So I think for the future of the team, it'll be smart to just use SolidWorks for the FEA. I've seen a lot of other spaceport teams and also FSAE teams use SolidWorks primarily, and they do just fine. So I think we'll be good with that. And then with the mix of ANSYS as well. You can see the decision matrix there just to see how they objectively reach the decision. And then if you could give it a read, that'd be great. It's a good example of a trade study, especially for Charlie and Preet if you're interested. And I think that's a good place to start. Now moving on to some of our upcoming tasks. I've split it between our validation and design team. So on the validation side, we have the Zenith questions and data sheet along with the ROCSIM Zenith file. And for the design team, the CFD projects, the recovery detailed CAD finally got word back from Carlos. And then the FIN FEA, the landing force and launch, which I'll go ahead and talk about all of these in more detail. So for the Zenith questions and data sheet, it's pretty much just a list of questions to answer in preparation for competition. There is a session at competition where we can set up kind of like Cat's Back for our org, kind of a poster session where judges and a bunch of different people can come and walk by and ask us really anything about our rocket. So we not only need to understand all of analysis and what we have done, but also what all of other sub-teams have done and kind of where Zenith is and, I don't know, developing a comprehensive understanding of Zenith. I do need to go through and create more questions that are relevant to analysis, because if you do look at the doc now, which I guess I'll send in the Discord, I forgot to link it here, but there are a lot of analysis questions from last year, so more relating to data collection and sampling, where that's not really our responsibility anymore. So I'll talk to Goose and we'll see if we can get more relevant questions there, and I'll come up with some as well. But Will and Amy, if you could take care of this, that'd be great. I know it's during spring break, so I don't expect you guys to be getting work done, especially after all the work we put in throughout the semester. So I think 2 weeks after spring break ends, if we could get all of analysis done and then start venturing out into other sub teams and offering help there as well. And that would be great. Now the ROCSIM Zenith file. So as you know, our open rocket file is almost finalized, and the only changes from here should be based on how the parts fit together. I know once we start physically assembling things, there'll be minor changes here and there. Hopefully nothing too crazy. So just apart from making those changes, the open rocket file is pretty much done. So now we need to shift our attention to ROCSIM and develop a corresponding ROCSIM file. This will offer us a good comparison of values, hopefully more realistic than what OpenRocket can give. And the computer in the lab does have ROCSIM installed. So when we do get in the lab post spring break, then we can start working on there. And I think there is already a ROCSIM file with the boat tail, but there are a lot of things that are different on there. So just touching that up is really what we need to do. And then something for us to look into is really the differences in the simulation results that we get. And then looking at what paint finish, the different fin geometries, and the boat tail do to our apogee and stability and different things like that will be really interesting to see and good to have as a comparison so that when we do go to spaceport, we're able to say, we can confidently predict we're going to go to this height or this apogee because of these factors. And, we used multiple softwares to confirm this. So this is also Will and Amy, and I guess it's up to you guys to decide which one you want to take on, the RockSim or the question sheet. But hopefully you do help each other out. And then this shouldn't take too long just because we have that file already. So it's more finishing that up. So if we can get that done a week after spring break, that would be excellent. Now moving on to our design team, starting with the CFD projects. Now I know, Nico, you put in some good work already. I'm just not too sure what exactly you've worked on yet. So kind of wanted to, I guess, outline some of the major analyses I wanted to see. The first being the nose cone analysis. So looking at different types of nose cone profiles on Zenith, and then just validating our decision. I believe you started work on that already because you were asking some questions in the Discord. Yeah, that would be great if you could continue to work on that. And then the boat tail validation. I know way back when you're introduced to the team in the library, we were talking about having a simulation with just kind of the standard flat end with how Oberon is versus our boat tail. So that side-by-side comparison will be really good for the tech report and our justification and the decision to use a boat tail on Zenith. And then just wanted to ask if you had plans for the surface roughness analysis, because it's a huge part of our, I guess, apogee impact with OpenRocket, and I'm sure it will be with RockSim as well. So being able to see how different surface roughness values impact apogee using ANSYS, that would be great. And then I guess we can talk about this more as you come closer to completing these, but writing a quick analysis report on the work that you do would be necessary, and also make it a lot easier once the tech report comes around. So I know Preeth was added and you've been talking to him. So if you guys want to go ahead and work on that and continue the work that you've been doing, that would be great. But really for these 3 analyses, I think if you could get them done a week after spring break as well, then it'll put us in a good position just to continue on and see where we're at for the tech reports. Now the recovery detailed CAD, Carlos reached out and he would like analysis to help recovery CAD the bulkhead. There's a list of components that he wants us to CAD, but really I think we should just meet up in the lab so we can physically see it and maybe start to draft them up instead of kind of conveying it through pictures and also taking dimensions in the lab. But Nikolai, I know you've been carrying our CAD so far, so this is kind of on you and also anyone else on the design team who wishes to help out. Shouldn't be too long, and I don't think he's looking for it to be that detailed, at least in terms of each part, but putting it together shouldn't be too bad. So also do 1 week after spring break. Lastly, the Fin FEA is something I've just been recently thinking of with our finalized Fin decision, but I wanted to see if Omar and Arturo, our FEA kings, can simulate the landing forces and also the launch conditions, because I know it'll be constrained differently because we'll have a different MMM and a completely different setup to Oberon. You will have to wait, I think, to complete the launch analysis just for the MMM design so that we know where to constrain the fins and how it's all going to work together with the lower airframe and the boat tail. But for the landing forces, I wanted to ask if the hand calculations from the boat tail FEA are accurate enough, because I know we had some debate about the validity of the results that we found there. So I think verifying those and then maybe testing a carbon fiber fin in SolidWorks, just like we did the boat tail, would be perfect. So the landing forces shouldn't take too long, but because the MMM design is still up in the air and to be finalized, 1 week after the final MMM design is submitted, I would like for all of this to get done. And then don't forget the corresponding analysis report. It doesn't have to be too long, and you can actually auto-generate it on SolidWorks, so that shouldn't be too bad. But that was everything. So if you do have any questions, then feel free to shoot a message on Discord or reach out to Irvin, Gustavo, or I, and we'll be sure to answer any of your questions. I think one thing I forgot to cover just for Charlie and Preeth, think about which sub team you'd like to be on. If you are not sure and you kind of want to get a taste of both, then that's completely okay. And you can maybe take on some projects or just help out someone behind the project for each of the teams so that you can kind of see what you like or maybe see what you want to learn more of before diving into it. But yeah, the teams are pretty flexible. If you're interested in something, you can move around. I don't have an issue with that as long as we have somebody being responsible and taking care of the work. Yeah, I think that was it. Excited to work with you guys. I know you've been doing such a great job, and really excited to see all of our work together come together at competition. And I guess I'll see you guys after spring break. Thank you.